Today, we're going to continue with understanding the formula of the area of the circle, which is pi r squared. Now, today, uh, we're going to use a different method, which is using a triangular method. Now, yesterday we use a rectangle. We transform all of this circle into a rectangle. Well, a rectangle. Well, a rectangle. So just rub that out. Okay. So yesterday, this is what we did. So we cut this into infinite pieces and rearrange it into a rectangle. Today, we're going to use a triangle instead. So what we do is you draw a circle, and in that circle is you draw a little circle. And then you draw another smaller circle. Well, let's have our starting point in here all the time. Yes. And this will really take some time to do, but we have time and we're not in a hurry. So it's really, the circle will be getting smaller and smaller and smaller. And then after doing the blue circle, you do it again with black color, and so on and so forth. So you keep doing this until you fill up the circle with mini circles all the way down. So it does take some time, but I really suggest that you do it yourself as I'm doing it, because by doing it, you gain a better understanding rather than just looking. And that's really the key. Doing has its ways. People nowadays don't really do, they just watch. And I think you come to a different level of understanding when you do things yourself. And it's just going on like this all the time until you finish with the green. In reality, yeah, this is really infinite circles going in here. But this is just for demonstration purposes. Now, what we do next is really then lay it out in a triangular form. And you'll see what I mean by this. And so what we're going to do is take that black line here outside and take it and make it into a straight line. That's really what we do. So this is the black line outside. That's the longest, length, because it's the biggest circle. And so then we take, so this is that line here. Yeah, this is where it begins and where it ends. Now we take the red point in here, the red point, and we stretch it next to the black line. But this one is just stopping short, right? Stopping short. And then we take the green line here, and then we lay it down here as well. They start at the same time, but it's shorter than the red. Now I want you to keep doing this all the way. So now we have, after the green, we got the blue. Yes. So that's the blue one here. And then you keep doing this all over again until you use up. Yeah. And then what's after the blue, you go back to black again. Now, what do you think would be the shape of this at the end? Yeah, can you guess? So you keep doing it until at the end you got the last mark in here. And what you have here is the shape of the triangle. So you just transpose, this whole thing here is now a triangle. Yeah. So it's a different way. Yeah. So yesterday we transformed a circle into a rectangle by cutting it in different places. This one, we transform a circle into a triangle by using a series of circles of different colors. And here we're going to count, we're going to analyze what is this all about. Now, all of this length in here, yeah, this one here, this series of beginnings in here is essentially this. It goes in. So this one here is the beginning of the black line and we stretch it. Yeah. The red here, yeah, is the beginning and we stretch it, yeah, all the way. So this one here, yeah, what's the value of this? Yeah, this one in here from the beginning all the way into there. Yeah, what is that? That is the radius of the circle. That is R. And so this series of piles in here is really, yeah, the height of the triangle. Yeah, the height of the triangle is really equal to the radius of the circle. That has to be, yeah, uh, put in the mind. Yes. Now, what about the black line here? Well, the black line, what is that? Yeah, that's the perimeter or the length of the circle, and that is the circumference. The black line is the circumference. And what is the circumference? How do you get it? It's 2 pi r or 2 pi d, but we use this here. So the value of this line here is 2 pi r. Yeah. But the inside, yeah, of the circle, including the outside, the black line, yeah, it's the area. And we already put it in here. It's the area, the same. So this area of the circle here should be the same as the area of the triangle that we just drawn. Now, what's the area of a triangle? Well, the area of a triangle is, if you this is elementary maths, is 1/2 base times height. Yeah. Now, how did they get this? Is a separate video that I made in the past, and I'll post the link somewhere in here. Now, that's the area of the triangle. So if we substitute 1/2 times, what's the base? Well, the base is 2 pi r. Yeah, this is the base of the triangle. So the base is going to be 2 pi r. Now, what is the height? Well, the height is r. This is the height in here, which is equal to the radius. And so now you can see here, yeah, by just looking at our previous lessons, yeah, is 1 times 2 is 2 divided by 2 is 1. So essentially that's cancelled and what you left is 1. 1 times pi r is pi r. You multiply by another radius, your answer would be pi r squared. So in a way, the area, yes, of the triangle, the area of this triangle is pi r squared, which is the same, yeah, to the area of the circle. So the area of the circle is equal, yeah, to the area of the triangle. I hope that's really clear. So in this sense, yes, that's why our area of the circle is pi r squared. That's really important. So here the area really is pi r squared, and that's the same area in here. Area here is pi r squared. Yes. I hope that's really, really clear. Let me know. And again, your homework. I always give you a homework. Homework, I'm going to write it in here. Homework is I'd like you to study and practice explaining to the class, in front of the class, how to derive the formula of the circle by transforming it into a triangle. To a triangle. I hope you'd learn something from here. And in the next video, we'll just really work with the formula and how to manipulate it. And see you in the next lesson.